Hello everybody, we're Group M4. My name is Tim Cottle.
I'm Noah Burton.
I'm Brandon Burt.
I'm Sidney Castillo.
And today we will do a review of additive manufacturing in biomedical applications due to recent clinical research. Additive manufacturing includes technology and processes that create three-dimensional structures through additive layering of material. This material is not limited and constantly advancing. Right now, materials can range from liquids to powders and plastics. This technology is also designed to create complex structures that reduce waste and increase efficiency compared to their production counterparts. In this presentation, we will review how additive manufacturing is changing the medical world and where future projections of its applications will lead. These applications include external prosthetic design through simple home-owned 3D printers, human tissue and organ design through delicate inkjet printing, and how surgeons are developing preoperative plans through the use of stereolithography technology.
Printing prosthetics. Soft tissue prosthetics are commonly used in the maxillofacial rehabilitation for prosthetic ears, eyes, and noses. These prosthetics are easy to fabricate and can even be made at home with a cheap desktop 3D printer. The body part that is desired is first scanned using a 3D scanner, then a mold is designed on a CAD program. Once the mold is designed, it can then be printed with a 3D printer. The material that is usually preferred for the mold is ABS for its durability. After printing, the mold must be polished with acetone to remove the staircase effect. This will leave a smooth finish on the end product. The mold is then injected with a medical-grade silicone and left to solidify. After solidification, the prosthetic is then ready to be removed from the mold and fitted to the patient. Some prosthetics made with this process can be manufactured for under $30. Advancements with this technology are being made every day and will be integrated into our everyday lives in the near future.
Modern-day prostheses are extremely expensive, costing upwards of $10,000. 3D printed prosthetic hands create a cost-efficient way to increase the quality of life for those with disabilities, especially for children whose limbs are constantly growing. With minimal measurement constraints, these prostheses can be printed and fitted at home using an everyday 3D printer. Most prostheses are made of plastics such as PLA and ABS. This prosthetic works with the use of elastic cords, which extend from the upper arm down to each finger. When the user bends their wrists, the fingers will curl towards the palm. 3D printers will soon be able to offer many other benefits, such as multicolor printing, which will give the prostheses a more appealing and realistic look. Many other materials are becoming more compatible with 3D printers, such as metals and ceramics. This will make the prostheses more durable.
Creating a living structure is difficult. There are many biological components that must be taken into consideration. For example, there must be living cells, growth hormones, nutrients, and scaffolding materials injected into the desired structure at controlled volumes and specialized locations. So how is this being accomplished? Well, first, Bioink is a new printing material that contains living cells that can be injected into these structures. Yet, it is the additive manufacturing process that actually makes this possible. The leading technology is thermal and piezoelectric inkjet printing. Through this deposition-based technology, a heating or electrical actuator allow low viscosity of the bioink, creating droplets that can be delivered precisely into 3D location into delicate structures. The deposition process does not exceed temperatures that kill the cells. Thus, it is the suitable technology in this day and age. So why is creating human tissues and organs so important? As the research and technology develops in future years, specialized organs can be created for transplant patients that would typically endure long waiting periods. This can also lead to fatal outcomes. These organs can be designed to have perfect biocompatibility with any patient, which also reduces rejection potential. They can even be created to assist in disease control and prevention, allowing this technology and research to truly advance the medical field. The diagram on the right shows a trachea model. This model was the first 3D printed organ to ever be implanted into a patient. The patient who received this had a black trachea due to smoking. This shows how revolutionizing this technology can become.
Surgical planning. CT and MRI scans are used to provide doctors with information about the internal structure of the body. However, this cannot prepare doctors for surgery, since this is a 2D representation of a 3D object. Therefore, doctors have begun to use CT and MRI scans and convert these into STL files of the patient's internal organs. These STL files are then inputted into a stereolithography printer, which is capable of rendering the object. In this additive manufacturing process, it uses a tank of liquid polymer, which is hardened by laser by exposing the polymer to UV light. Doctors are able to use this physical object to gain a better understanding of the patient's unique case. This understanding helps doctors to plan the surgical operation. Advanced pre-op surgery. In the future, doctors may be able to use a biological replica of the patient's organ. This will provide even greater detail than a plastic replica for doctors to study. With advancements in virtual reality, doctors can be able to do the operation in a simulated environment. This could allow for edits to be made if mistakes occur. With the movements of the doctors being recorded, robots can then replicate the actual surgery on the patient.
These three applications in the biomedical world are just scratching the surface on what additive manufacturing is creating for the medical community. Engineers and doctors are working together to tackle everyday problems that were once deemed impossible to overcome. And this technology will advance in the future to save many lives and revolutionize how we approach medicine. Thank you for watching.